right, I am doing a video of 7.4 today. It's a pretty short section, so I'm just doing it this way instead of the traditional lecture. On my screen, you can see I have two identities. Well, two sets of identities. I've got the sum to product and the product to sum. So these identities, I like to have them referenced in a list while I'm working the problems because you guys, these identities are not easy to remember. Even I have trouble, with the subtle differences and the plus and minus and stuff like that. So always good to have these out for a reference as you're working these problems. So I've got my formulas here, or my identities, and I am going to start with this problem over here. So I need to find the exact value of the expression. So you guys, exact value means that I'm not going to have to put it in my calculator. These actually will end up working out to be angles that are on your unit circle. So I know I can get the answers exactly. So let's start with this first one. What we're looking for here is matching this to one of these lines over here. So what I have is I have a cosine plus a cosine. So with that information, it looks like I'm going to use this first line here, cosine x plus cosine y. So when you have the cosine of something plus the cosine of something different, notice these are two different angles, I can rewrite them as a product. So that's what I'm going to do. So I'm going to take that cosine 5 pi over 12 plus cosine pi over 12, and I'm going to write it as this product. So it looks like it should equal 2 times the cosine of, now, x plus y over 2. So in our case, 5 pi over 12 is the x, pi over 12 is the y. So x plus y, and then it's over 2. Now, that's the first part of it, and then that's multiplied by the cosine of x minus y over 2. So it looks really complicated. You guys, these have common denominators, so we can just add the numerators. So let's do that. So I've got 2 times the cosine of, you guys, 5 pi over 12 plus pi over 12 is 6 pi over 12. And yes, I can reduce that. Don't forget, it's still over 2. Cosine x minus y, you guys, 5 pi minus pi leaves you with 4 pi over 12, and that's over 2. Okay, guys, when you have a fraction and you divide it by 2, there's two different ways I could go about this. I could take this top number 6 and cut it in half and get 3 pi over 12. That's one way to do it. So 6 pi over 12 divided by 2 is going to equal 3 pi over 12. Think about taking your 6 pi over 12 and cutting it in half. What is half of that? Well, it's 3 pi over 12. It's probably the easiest way to do it. Remember, you could also flip and multiply. You could do 6 pi over 12 times 1/2 and get 6 pi over 24. And that does simplify to 3 pi over 12. So either way you look at it, we're cutting that in half and getting 3 pi over 12. I haven't reduced yet. Let's do the same thing here. I have 4 pi over 12. I want to cut that in half. So now I have 2 pi over 12. Okay, so let's reduce. I've got 3 pi over 12. Let's take 3 out of the top and bottom and get pi over 4. What is 2 pi over 12 reduced to? Well, that reduces to pi over 6. Now you can see these angles that I know are on my unit circle. So if you're not familiar yet, or if you haven't memorized your unit circle special angles yet, that's okay, because you can always have that to reference. But here is where you actually do take the cosine of pi over 12 and the cosine of pi over 6. So I've got the 2. So cosine of pi over 4, go ahead and write that in. You guys, that's root 2 over 2. cosine of pi over 6. What is that, guys? That's root 3 over 2. Remember, that's a 2 over 1. We can multiply all 3 of these terms together straight across the top and across the bottom. So remember, guys, because these are both square roots, you can multiply those numbers under the root. So we're going to have a 2 and a root 6. And on the bottom, we have 1 times 2 times 2, and we're going to get 4. You guys, we can reduce this. Remember, you can't touch this because it's under a square root, but you can reduce the 2 over 4. You can divide both of those by 2. On top, you would just get 1 root 6, so we'll just say root 6 over 2. So you guys, this would be your exact answer for this first problem here. Now, I'm going to clear that work, and then we're going to do the next problem. Okay, so let's look at this one. I've got sine pi over 4, sine pi over 12. Notice there is not a plus or minus here. This is starting as a product. So on this one, we would be looking at the product to sum. So you have to be really careful. On the first problem, we had a sum. Now, if there is a minus here, it's still called a sum. Plus or minus are both sums in general speaking. So I started with a sum, and then I wrote it this way, which was a product. But here, I'm starting with a product. So if I start with a product, then I must be turning it into a sum. So find the product that looks like sine x times sine y. And you guys, I think your identities, let me pull them up. Oh, hold on. I gotta get off a draw. So you guys, I want you to notice the difference. I usually use these identities here that I have in this picture. Notice the 2 in front of all of these products. Notice how your product to sum formulas are different in ALEKS. Now, they're different, but they're the same. So notice in these formulas, there's no 2's in front, but we do have a 1/2 in front on the other side, which means they took these basic identities here and they divided both sides by 2. So when you're looking on the internet, looking for a good reference sheet, and I'll be posting one when I find a really good one that you guys can reference while you're doing your work or taking a test, you might see it this way with the 2's in front, or you might see it this way like ALEKS does it, where they divide both sides by 2 and then there's a 1/2 on this side. Both things are going to work out the same way. Because ALEKS writes it this way, they don't have the 2 in front. That's why your problem doesn't have a 2 in front, because it most matches this identity. So even though we could go either way here, I've traditionally used the one with the 2 in front. Instead of that, I'm going to use the one that ALEKS has for us. And you guys would have that if you clicked on explanation. You can see how ALEKS likes to write these identities. But you guys, if I'm looking at the ones ALEKS has for us, I've got sine x, sine y, or in this case, you guys, ALEKS is using u and v, but it's sine sine. It's a product of 2 sines, so it's this last one here. So sine x, sine y, so my x is pi over 4, my y is pi over 12. Let's write that on the other side. It equals 1/2 times, and you guys, because of the way they've divided this entire side by 2 to get rid of that 2, that 1/2 has to apply to everything else in the formula. So make sure you do bracket that. So I've got this 1/2, and then I've got brackets. It looks like we do cosine u minus v, or x minus y, however you want to say it. So pi over 4 minus pi over 12 minus cosine pi over 4 plus pi over 12. I'm running out of space, guys. Let's pretend that one bracket isn't there because I don't know how to erase it. All right, so that's what we have. Now I'm going to take off the explanation so we have more space here. All right. So let's see. All right, so I need to continue working this problem. Oh, eraser, guys. Oh, look at that. Perfect. Okay, so I'm going to continue working this problem. So we've got the 1/2. On the inside, we do have to add pi over 4, or sorry, add and subtract pi over 4 and pi over 12. These do not have common denominators, so we're going to have to get common denominators. We're going to leave this one as pi over 12, but you guys, we need to make this into something over 12. So be careful when you're finding equivalent fractions. What we have is pi over 4. It needs to be something over 12. So how do I get from 4 to 12 on the bottom? I had to multiply by 3. How do I do it on top? I have to also multiply by 3. So I have 3 pi over 12. So in here, I have 3 pi over 12 minus pi over 12. And then there's a minus and then a cosine. You guys, instead of pi over 4 here, I'm going to write it as 3 pi over 12 plus pi over 12. All right, now we can do the add and subtract. So here I have cosine. 3 pi minus 1 pi leaves us with 2 pi over 12. Minus cosine. 3 pi plus pi, well, that's 4 pi over 12. So I have 1/2 times the cosine. Let's reduce that so we can see our special angle. Pi over 6 minus cosine of, what is this 4 pi over 12 reduced to? That's pi over 3. All right, now we put in what we know, guys. What is the cosine of pi over 6? That's root 3 over 2. What's the cosine of pi over 3? That's 1/2. So you guys, you do need to subtract in here first. Remember, the 1/2 has to apply to everything. So you could multiply both of these separately by 1/2. I would just put them together. They have the same denominator, so I'm going to go ahead and put these two fractions together as 1. And then the last thing I'll do is the multiply by 1/2. So because they both have a 2 on bottom, you can just subtract. Now you can't actually subtract 1 from root 3, but you can just write it like this. So root 3 over 2 minus 1/2 is just root 3 minus 1 all over 2. How do I multiply by 1/2? Well, I divide by 2, or think about it, you can just double the denominator here. And just do the 2 times 2 down here. So on top, we have root 3 minus 1, and on the bottom, we'll have a 4. So this is your answer here. So you guys, this is a lot of fraction work for the most part on these problems. But, I mean, other than fraction work, we're just plugging in. We have a formula, we're plugging values into that formula, and we're being careful on which formula to choose. And remember, if you don't like the 2's on the outside here, you can use the way Alex writes it and just, you know, look under your explanation for how it looks there. Okay. All right, so let me clear my drawings. I'm going to look at a couple other problems, make sure nothing worrisome or different or surprising is going to come up here. That one looks pretty straightforward, guys. Notice this one's in degrees. Remember, your answers on these are just numbers, so it doesn't affect your answer, but you might be more comfortable adding and subtracting degrees. So it's probably even easier than the first one we did. Yeah, these all look pretty standard, guys. I'm not seeing anything pop out at me that would have anything that I haven't gone over yet. I'm looking for something specific, but it's not showing up, so I don't think you'll see it. Nope, they all look pretty straightforward, guys. All right, so let's go to, oh yeah, you can see one of my kids from years ago. All right, let me go to this second type of problem. Now, where'd my identities go? All right, guys, it took me a while to get this screen organized perfectly the first time, and then I just ruined it. So I've got to figure out where my identities went. Oh, perfect, guys. Here we are. So you guys, this is a different kind of problem. Notice we have variables here, which means my answer, I'm not going to be looking for a specific answer. This is more of a take this expression and write it in a different way type thing. So it says use one of your sum to product formulas to rewrite sine of 7b minus sine 2b as a product. So remember, even if it's a minus here, it's still considered a sum when we say sum to product. So minus, plus, either way, it is a sum that we're rewriting as a product. So it's going to be one of these. So look, we have a sine minus sine. So you guys, that is this last line here. So sine x, so our x here is the 7b, minus sine y, our y is the 2b, equals, well, it says it equals 2 times the cosine of x plus y, so 7b plus 2b over 2, times sine of x minus y over 2. So look, you guys, the first one we used was the top line in the other problem. Look at the subtle differences between these two. They look a lot alike, but like in this one, this is sine instead of cosine. So you really have to be careful. Make sure you're only looking at the line you need when you're using these identities. Oops. Okay, so let me erase that since I know how to do that now. All right, so let's continue to work this problem. So 7b plus 2b is 9b. No, hold on. I'm writing cosine, what I told you to be careful about. All right, so I have 2 times the cosine of 9b over 2 times the sine of 5b over 2. Now, guys, we don't know what b is. So there's nowhere I can go with this. 9 has b, 5 has b. I can't reduce those fractions. I am going to see if they turn those into decimals. Sometimes Alex does weird things with inputs, but they probably just leave it as a fraction. So let's look down. Yeah, look, guys. They just write it exactly like we wrote it here. So 2 cosine 9b over 2 sine 5b over 2. There's nowhere else we can go with that. So these are probably on the easier side of the problems that you do for this section. Let's look at another one. All right, so this one's going the other direction. We're starting with a product. Why is this a product? How do you know it's a product? Well, because the two cosines are right next to each other. There's not a plus or minus here. So this is a product, and I write it as a sum or difference. You guys, we have identities called sum and difference identities. I don't want you to get that confused with what we're doing here. Remember, in a sum and difference identity, so this happens a lot, guys. People get confused and they do the wrong identity here. So hopefully to help you see that it's different, using a sum or difference identity is when you have two angles subtracted or added together with one trig function. So notice this isn't sine A, sine B, or cosine A plus cosine B. This is sine of A minus B. The sum or difference on those identities happens within one function. And so you really do have to know the difference between the two, because like I said, a lot of people see the word sum or difference and then they go straight to these. So be really careful on which ones we need at what times. But you guys, this looks like a product that we need to write as a sum. So I'm looking at the product to sum formulas. I have cosine, cosine. So I have a cosine times cosine product. So on my list, I see that it would fall with number 1. But remember, in ALEKS, they don't use the version with the 2 in front. So I'm going to show you ALEKS list, and we can look for the one that more closely matches your problem here. So cosine times cosine is going to be, you guys, it's going to be this line here. Cosine U, cosine V. So cosine 4z times cosine 2z equals, well, it equals 1/2, and then a bracket, cosine u minus v, so that's 4z minus 2z. Then it's a plus cosine u plus v, so 4z plus 2z. So let's double check, make sure we're looking at the right line. We got all the pluses and minuses in the right place. We're on cosine, cosine. We've got cosine plus cosine. In here we have the minus and then the plus. So that's what we're going to use. So let's use it. So let's simplify this. So I've got the 1/2 out here. So 4z minus 2z is just 2z. 4z plus 2z is 6z. And you guys, there's really nowhere we can go with this. Again, I'm going to check if ALEKS does anything different than, takes it any further than I have here, because there's not a lot of place it can go. So one thing that it looks like they've done is they have distributed this 1/2 to both of these terms separately. So see, their answer down here has, instead of having the 1/2 out front, they did distribute it to both terms separately. So let's go ahead and do that for our example. So they have 1/2 cosine 2z plus 1/2 cosine 6z, like that. So they got rid of brackets. So we'll keep our answers like that, guys. Again, I'm going to look at these problems, see if there's anything that sticks out at me that might give you trouble. 7/5, that looks fine. So again, I'm looking through these problems for a specific situation that might throw you if you came to it, but I don't see it showing up, which means it probably won't. It's kind of a little more complicated of a thing. You just never know with ALEKS. If something comes up, guys, in ALEKS and it gives you something we haven't dealt with here in this video, of course, definitely get with me. Sometimes ALEKS will surprise me on the questions it might give. But these are all looking the same. They're pretty standard, guys. All right, so that's it for this section. So not a lot going on here, just using formulas. Just have to know which ones to use. Like I said, I don't want you to get confused I didn't realize that Alex used a different version than I did of the product to sum when I started the video. This is the one I usually use, but guys, because they use a different one, I would suggest using the one in Alex. You guys, I would suggest using these right here for product to sum, the ones with the 1/2 over here, because that's how your problems are going to be laid out for you. And you guys, like I said, I'm going to find an identity sheet that has all the identities that you should know, and I'm going to like email it out to you as a good reference sheet to use on tests or something, and I will make sure I find these that are like the ones in Alex. All right, guys, so I am going to end this video. So I will see you guys later. Well, I don't actually see you guys, do I? I will talk to you guys later. So, all right, bye.